For the exam review, let's skip this problem number 1 in this section 13.4. Let's skip number 1 and let's go on to the next problem. So let's take a look at problem 2. Problem 2 has 2 blocks, one of 8 pounds, one of 6 pounds, and there's a spring between them. It's compressed. Point 2, determine the acceleration of each block just after they're released. So let's take a look at that. Again, we have these 2 blocks. This one is 8 pounds. And then there's a spring between them. This one is 6 pounds. And the spring force is, notice the spring is compressed 0.2 feet. So it's going to be 0.2 times the spring constant. And the spring constant is 20 pounds per foot. So that's going to give us a spring force of 4 pounds. So we're going to have 4 pounds pushing this way, 4 pounds pushing this way. And there's going to be friction on this side. And of course, the normal here is going to be 8 pounds. Normal here is going to be 6 pounds. And so the friction here will be, of course, mu and C. And our friction is 0.2 times 8. So it's going to be 1.6 pounds of friction force. Over here, friction force, again, it's going to be 0.2 times 6 pounds, which is 1.2 pounds this way. And so this is our free body diagram of A and a B. So let's just look at each of these. So for block A, F equal MA. And I'm not sure which you can call, maybe since it's moving in this direction, I'll call this positive, but you can do it whichever way makes sense to you. So if we call this direction positive, the friction is going to resist the motion. And the spring force will go in the direction of the motion. And our mass is 8 divided by 32.2. And acceleration times acceleration. And again, our friction is negative 1.6. Our spring force is 4. And when you solve for A, you get 9.67 feet per second squared. Now let's look at block B. F equal MA. Once again, I'll call the direction of the motion positive since it's going to be moving this direction. I'll call this one positive. Again, you can do it either way you like. And there's, again, friction that is against the motion. and the spring is in the direction of the motion. Our mass is 632.2 times acceleration. And we have negative 1.2 plus 4, 2.2 of that. Then the acceleration on this one is going to be 15.03 feet per second squared, like that. Next, let's take a look at this problem. There's a 4 megagram truck. It's traveling at 15 meters per second, and the brakes are applied, causing it to skid a distance of 10 meters before coming to rest. Determine the constant force developed in the coupling C and the frictional force between the tires of the truck and the road during this time. The total mass of the boat and the trailer is 1 megagram. So let's take a look at this. So first of all, we're told that it comes to zero velocity after skidding for 10 meters. Now, we're not told anything about time, so we're probably going to have to use an equation that does not use time. So again, we have the truck and the boat slash trailer. And now, as I mentioned, we don't know anything about time, so we're going to have to use this equation, which relates the velocity to distance. So we'll have, let's say, V2 squared is equal to V1 squared plus 2 times the acceleration, S2 minus S1. And we're told the final velocity is 0. And the original velocity is 15. And it comes to stop in 10 meters. So you can call that 10 minus 0. So the acceleration, or I should say deceleration, is 11.25 meters per second squared. So next we can find the total friction required to stop the whole system. So let's do, so for the whole system here, let's do summation F equal MA. And again, the only force on this is the friction. And so it's going to, oh, excuse me, this, the acceleration here should have been negative. Please fix that. That's going to be a negative. In any case, so we have, let's say it's moving, let's say in this direction. Let me call this direction positive. And the only friction, the only force we have is friction that's going to resist this. And we have MA, and then friction and our mass is a total of 3,000 kilograms. The mass of the two objects. And then the acceleration, mass 11.25. And so the friction force is going to be 33,750 newtons. So now they also want to know the force on the coupling. And so we can focus on one object or the other. Let's focus on the boat and trailer. So let's make a free body diagram of the boat and trailer here. And so again, it's going to be 1,000 kilograms. And apparently there's no friction on it. Apparently the wheels are free to roll. The friction all came from the truck. So the question is, how much these are moving along? What's that force from the coupling pushing back on the boat and trailer? And again, if we just do summation F equal MA, it's going to be this force. Once again, let me call this direction positive. So that's going to be going in the negative direction. Negative F is going to be 1,000 times. And of course, the deceleration is going to apply, just as much the boat and trailers to the truck. So that's going to be the decelerations negative 11.25 meters per second squared. And when we calculate that, the force on the coupling is going to be 11,250 newtons. Force on the coupling. So next, let's take a look at this problem. We have a truck moving along the road and has a crate in the back. And the truck wants to accelerate to a speed of 60 kilometers per hour. Wants to have the shortest time that can accelerate so that the box does not slip. So let's take a look at this. And now this is really a question when I ask you, like, say, the shortest time to get up to some sort of speed, that means we're always going to have to find acceleration in that case. So that's what the first thing we're going to be looking for will be acceleration. So let's take a look at the free body diagram of this crate. So we have 200 kilograms times 9.81. And that's going to give you 1962 newtons. Then we'll have a normal reaction. And then we're also going to have a friction force. So again, the idea is the truck is moving this way. And then the box, we don't want it to slide off this way. So we're going to have a friction force like this. And of course, that's always mu and C. Now, of course, the normal here is going to be 1962 newtons, like this. And so this is going to be the coefficient of friction is 0.3, 1962, which is 588.6 newtons. Like this. And so let's sum the forces in the x direction. But it doesn't really matter which direction you call positive. I'll call to the left positive, but either way would work. And so here we have a friction force. Then we have a mass of 200. And then we have our acceleration. And we said the friction force was 588.6 newtons times 200. So acceleration in the x direction, when you put this into your calculator, is about 2.943 meters per second squared. And so now we want to find out how does that relate to time. Now the final velocity we want is 60 kilometers per hour, or again, that'd be like 60,000 meters per hour, divided by 3,600 would give us the meters per second. Should be 16.67. So that's going to be the final velocity that we want, and we want to find out. And of course, this is the maximum acceleration we can have. So if we use our equation, v naught plus at, and it's starting from rest, but we want it to get up to this speed, 16.67. Starting from rest. And the maximum acceleration, we can have 2,943 times time. And when you put that in your calculator, you get something like T is 5.663 seconds. It will be the quickest that it could get up to this speed without the box sliding off. Take a look at this problem. Conveyor belt is moving at 4 meters per second. Coefficient static friction is 0.2. Determine the shortest time the belt can stop so the package does not slide on the belt. So again, this is very similar to the last one. Instead of accelerating like we did in the last problem, this one we're decelerating, but the idea is all the same. So again, we have a picture like this, 10 kilograms. And then, of course, the normal. .1 newtons, and we want to keep this thing from sliding. And so there's going to be a friction force, again, as normal mu and C. Now, in this case, our coefficient of friction is 0.2. 98.1. And this is going to be 19.62 newtons, like this. Again, so if we want to keep it from slipping, we want to find the maximum acceleration, or in this case, I guess the maximum deceleration. Again, F equal ma. And the only force we have is the friction force. And let's see, so let's say if the box is moving this way, the friction resisting it from going this way. And so I don't know if you want to call, I don't know, maybe you want to call this way positive. It really doesn't matter. We don't only have the one force. So let's call, then we'll have just the friction force. Let me emphasize that. This will be the only force we have is friction. And again, we have a 10 kilogram. And we have acceleration and the friction force. Again, in this case, you can see it's going to be the way I've ordered this would be negative like this. And then so our deceleration is going to be 1.962 meters per second squared. And again, the original velocity was 4 meters per second. So again, this was moving. And so we're going to put this equation. And our original velocity was 4 meters per second. And we want our final velocity to be 0. And this should have been negative up here, this deceleration, by the way. Please fix that. That should be negative. Negative 1.962 times time. Time is equal to 2.04 seconds. That's the shortest amount of time that can decelerate so that it doesn't slide off the belt. Again, very similar to the last problem.